So the integration by substitution that we've done so far has been with indefinite integrals. There's one thing we do have to take into account when we work on definite integrals with substitution. So here I have the integral from 0 to pi over 4 of tangent x secant squared of dx. This is one of those problems that actually there are two different correct u substitutions we could do. The one most people tend to see because they're looking for composition where a function's inside another function, they see that secant is being squared. Uh, where they say that u is equal to secant x, which means the u dx equals secant x tangent x. And if I solve for dx, that would be 1 over secant tangent du. Now, we have to be careful here when we write this then, in that I want to think of this as integral from pi over 4 of tangent x, and then I'm going to split up the secant squared, the secant x times secant x. And the reason for that is I can already start to see ahead that if I plug u in for both in and have tangent x times secant squared, I'm going to have a secant x that doesn't cancel out in my substitution, making it a bad substitution. However, by splitting up secant squared into secant times secant, I can then have a good substitution. So it wasn't a poor choice. It was just I was substituting too much. So this would be the integral. I would have a tangent x and secant x that would cancel out. So u du. But notice I haven't written my bounds yet. And the reason for this is that, remember I said for this to be a good substitution, I can't have any x's at all. And that includes the bounds. The bounds that were given to us are when x is 0 to when x is pi over 4. Well, I need to make sure that even the bounds are in terms of u. But fortunately, we know how to find u. So I just need to plug my bounds into secant of x to find out what u is. Well, secant is 1 over cosine. Cosine of 0 is 1. So 1 over 1 is 1. For pi over 4, cosine of pi over 4 is 1 over rad 2. Reciprocal of that, which is secant, would be rad 2. So this is the integral from 1 to radical 2 of u. Well, antiderivative of u would be 1/2 u squared. In this case, I do not need a plus c because this is a definite integral, and the plus c is going to cancel out when I do the subtraction. Plugging in rad 2, I would have 1/2 times 2 minus 1/2 times 1, which is going to equal 1/2. And there is the integral, a definite integral using substitution.